So I'm going to get one thing out of the way. I didn't realize there was a theme for this event, so you'll notice my slides are themed wrong. I'm sorry about that. I'll fix that next time. For those of you who don't know me, I'm Laith Alissa. I work on Filecoin infrastructure at Protocol Labs. And like a previous talker said in this track, I bring no answers today, only questions. So what we're going to do is we're going to talk about Bootstrap nodes, their importance to the network, and some challenges we face, and hopefully inspire some thoughts and contributions in the future. Yeah, it would have been good to have that slide on when I said that. So after that, I'll talk about some of the things we're doing, some of the approaches we're trying to mitigate these issues, and what we're prioritizing in our current roadmap, and Q&A if we have the time, but given the schedule, that might be, in the social area later. Okay, so what are Bootstrap nodes? So Bootstrap nodes are participants in the network, but they're kind of silent participants. So they basically just sit there. They do three things. They participate in the gossip protocol, so they pass messages around. They maintain scoring, which is part of libp2p, sort of like a peer mechanic, which helps penalize badly behaved peers. Let's try saying that 3 times. And most importantly, they serve peer discovery requests. So if you have a passing knowledge, you might think, isn't this just all covered by libp2p or, whatever, one of those protocols anyway? Yes, it is, but Bootstrap nodes have a specific purpose to in this process. So if you consider a node which is already active in the network, it will be able to retain a set of peers itself. So as other peers are joining or leaving topics or the network, they send out notifications to peers they're connected to, and they're able to like self-manage. And that's sort of the essence of libp2p. Furthermore, they can utilize peer discovery mechanics, so they can actually like query the whole network through random walks to actually acquire more peers, and that's all fantastic. But if the node doesn't have any like pre-knowledge of the network, then how does it connect, right? This actually turns out to be like a more fundamental problem, and there have been discussions about this in the past. You can Google and find a number of GitHub threads where people touch on this issue. But the first time a peer wants to join the network, let's say like a Filecoin client like Lotus, they need to have an initial peer list. Otherwise, the previous things I mentioned are just like not available to it. So that's what the Bootstrap nodes do. So there are a set of static peers, as we call them, which somebody joining the network can look up and make an initial connection to, and then they'll get further peer information. And then they can go back to that previous slide where they're able to self-manage their peer sets. So what does that look like? So there are 3 main implementations of Filecoin. So there's Lotus, Venus, and Forest, and all of them do the same thing. They hard code a list of these peers into their code base, and that's vended into their releases. What's actually funny is that they've drifted at the moment because we actually have an additional Bootstrap peer that was recently added. So you can see that's actually available in Lotus, but that hasn't been reflected in these 2. So you can already see why this is a bad idea. So now to shoehorn an ill-fitting culture reference. He who controls the bootstrapper controls the universe. So as you might have surmised, that if I'm a client and I'm connecting to the network for the first time, I have to go to a Bootstrap node. That Bootstrap node could tell me anything. It could lie to me about the list of peers. I could be in a censored environment, and it could hide the network from me. If you know about what sort of Sybil attacks are, it could point you at like a collusion of peers which can work together to censor you, and all kinds of problems. So they're critical for the network. Yeah, so what does the landscape look like now? So we have 17 Bootstrap nodes listed well, I should say 17 listed in Lotus and 16 listed in the other 2 implementations. Protocol Labs operates 9 of them. Glyph and Venus run 1 of them each, which we are eternally grateful for. 2 we've recently found to be offline, and 4 are appearing offline, and we're investigating. So there might be some complications with routing there, but we're not sure. We're kind of like fairly confident they're not responding, but we're still trying to work that out. 16 of those 17 Bootstrap nodes actually run Lotus implementations. And running a Bootstrap node is actually pretty resource intensive. Maybe not to sort of the caliber of people who participate in the network like SPs, but to everyday schmucks like me, I'm not going to run a Bootstrap node because I don't have the CPU, memory spare, and I certainly don't have 500 gigs of disk space required to keep up with the chain. So what issues do we observe from those? What sort of, like, how do we formalize them? Oops, sorry, I need to stay close to the mic. Maybe I should, hello? Is that working? Yeah, cool. So to formalize them, Bootstrap control is significantly centralized, right? So Protocol Labs running them is kind of like an obvious starting point, right? We want to make sure the network is running effectively, but we need to move away from this model. It's not in the ethos of the network. Implementations are mostly homogeneous, as we discussed earlier in this track. When you have the same implementation running, a single bug can wipe out the whole network. As I only just learned today that Forest is heavily based on Lotus, so that makes me a little bit worried, but thankfully Venus has added one Bootstrap mode, which is hopefully not based on Lotus. I don't know. I may need to look into that. So they're not cheap or trivial to operate. Another problem with Bootstrap nodes is you have to keep an eye on them. If they crash, if you get corrupt state, you need to be monitoring and paging yourself and making sure you can get them back online. The Bootstrap list isn't efficiently updated. So previously I showed you that you actually have to make a commit to each of these code bases. That's actually vended into the release. So it's not like you can update the Bootstrap node and people running older versions of Lotus will get the new copy. That doesn't happen. They have to actually update Lotus to get the new copy, which is suboptimal. And the nodes are currently not efficiently or effectively monitored. So if they go down, sometimes we don't even know about it. Okay, so just diving in a bit more, I'm going to try and speed up because I'm conscious of time, but like I wanted to drill down into each of these. I'll just try and blitz through them. So what do we do about all of these problems? So these are the easy challenges. They just require work to do. They don't require problems to be solved per se. We can just call for more third-party Bootstrap operators. And to do that, we might consider if we need incentive in this space. Hopefully not, because hopefully everyone wants a healthy Filecoin network. So we might be able to persuade people who already exist in this space to help us out. The second issue, mostly homogeneous implementations. As I mentioned before, Venus have implemented and shipped their own Bootstrap node. Sorry, implemented and deployed their own Bootstrap node, which is now available in Lotus. And what we'd like to see is more Venus Bootstrap nodes and more Forest Bootstrap nodes in the Bootstrap list. The less easy challenges. It's not trivial and cheap to operate, as I mentioned before. Can I skip this? Okay, so I'm going to just skip a little bit ahead. So one of the major problems that have been reported by people who have approached to run Bootstrap nodes is the disk space. This is possibly one that we can actually deal with. So if you just direct just eyes down to this point here, on the initial peering requests, we have this thing called the Hello protocol, and that actually requires a heaviest tip set exchange between two peers. And at the moment, it doesn't seem that it's supported to not respond with the heaviest tip set from a Bootstrap node. It's possible that we can actually bypass this specifically for the initial Bootstrap request, which means a Bootstrap operator won't have to lug around a 500 gigabyte disk with them. So that's something that we'd like to look into. Bear in mind, this is sort of like a roadmap, like I don't want to say workshop, but these are things we're thinking of in Filecoin infrastructure roadmap. So if anyone has anything to contribute to or comment on, this is sort of the point in the presentation. I'll try and zoom through and we get to that stage as quickly as possible. So these are the actual really hard problems that we are trying to come up with solutions for. So if we were to imagine an ecosystem where Protocol Labs weren't running the majority of Bootstrap nodes. So let's just say like the average show in the community was running them, like the full fleet of them. So there's like 20 odd. We don't know where they're running. We don't know who's running them. How do we deal with monitoring, right? Because we don't want to be advertising Bootstrap nodes with poor uptime. Well, that becomes quite complicated quite quickly. So one naive solution is we could have just something that probes each of these Bootstrap nodes and then says, okay, it's been responding, 80% of the time or whatever. And that's actually fraught with some difficulties. So one thing that I realize I've skipped over, which I potentially shouldn't have skipped over, is how do we even get people in the community to run them? So if we are forced to provide an incentive, we have to actually validate that people are running a Bootstrap node. So if I say, we give them, we enforce it at the protocol level, or we just give them handouts for running Bootstrap nodes, we have to actually verify that they're doing the job of a Bootstrap node. And if we have a centralized monitoring solution, they might just be pretending that they're responding to us. So they could just say, oh, I know where, I don't know, Protocol Labs or Probe Labs or whatever monitor is coming from. So whenever they probe me, I'll give them a peer list. But whenever anyone else probes me, I'll just use, be mining Bitcoin on this box instead or whatever. So actually, like, an effective monitoring solution is really hard. And it gets even harder when you think about how to do a distributed monitoring solution, because you then have to worry about verifying the results. So this is quite a hard problem space. So this is something that maybe somebody who's a lot cleverer than us can maybe have a think about. Because ultimately, we actually want all of this stuff to be community concerns. We shouldn't be centralizing anything. And we all know the story. I'm not going to go repeat it to you all. And the final point is the list isn't officially the list isn't efficiently updated. So, like I said twice now, every time we have a change to Bootstrap nodes, we have to go and make a commit, a release, and then people have to pull in that new version. So we probably want another mechanic for that. We probably want to list the Bootstrap list somewhere public, and that would be all well and good. And you point your Filecoin implementation at this public list and use that to Bootstrap. That way, when we update the list, either due to nodes, badly behaved nodes being removed or new nodes being added, then you're always getting, a fresh-ish copy. So that's great. But again, that has this centralization issue. So who's holding the keys to update that list? How do we push that out into a decentralized fashion? Yeah, so the other important thing to point out about that is this knowledge is always out of band, right? Because as I mentioned at the beginning, if you're a new peer trying to join the network, you don't know anything about it. You could be joining a fake network. You could be joining a censored network. You could be being tricked into some joining via some colluded peers, which are going to cause all kinds of trouble. So the actual information about the Bootstrap nodes needs to be provided out of band, which they kind of are at the moment because you're getting them from a release on GitHub or you're cloning the code and building it yourself. So you are actually getting that out of band at the moment, and that needs to stay the case and going forward. Whew. Okay, so our current roadmap at the moment is focusing on those easy problems that I mentioned. So we're not going to try and tackle anything like decentralizing all of these components. We're just trying to harden the Bootstrap network. So we're trying to increase the implementations. We're trying to increase the number. We're trying to decentralize the Bootstrap presence, so have other people running them. And we're also raising awareness of solving some of these harder problems. So that's why I'm standing here at the moment. And we are communicating with other groups which are dealing with similar problems. So Probe Lab, a big shout out to them because they actually provided us a basic monitoring setup. Well, actually, I say provided. I mean, it's their own work. So it's called Boomo on the previous slide. It's a little screenshot of it shaming some of our Bootstrap nodes. They're not all ours. We're not that bad. It's just two of them that we were decommissioning. They picked up on when we didn't announce it. That brings us to endlessly complaining at conferences, which is what I'm doing now. Okay, so I might skip this slide because this was just a bonus. I wanted to basically point out the fundamental issues here. So just because of time, I'm going to skip the first part and just maybe spitball some ideas. So things that we've considered is some kind of incentive-driven protocol solution. But then that introduces like other issues, as I alluded to earlier. So how do we verify it? How do we stop people gaming it? And how do we provide a single point of reference for the Bootstrap node list that the community can update such that it's protected and you're getting a valid list. So one of the ideas we had was instead of actually having a Bootstrap service, we convert the Bootstrap node into constantly writing a log of the active peers. So you would have basically a historical records of peers that you can join, and that will just be available as if you queried a Bootstrap node directly. And the interesting thing about this idea is a client can make its own decisions about how to use that information. So you don't necessarily need to just take the latest copy and go, oh yeah, I'll connect to these peers. You can look at the full history and the changes of peers over time, and you see, oh, that peer has been part of the network for 2 years or whatever. So I'll select that for my bootstrapping, and you can do whatever you want. It's all like sort of at the discretion of the client. But yeah, so with that, I'm just going to wrap up. I apologize. There was so much more I wanted to go into, but just because of time, I wanted to keep it keep your afternoons free or evenings now. So you can find us on Filecoin Slack, Phil Infra, and that's my handle if you want. I'll upload the slide deck at some point, so you can just click through on that. Does anyone have any questions, comments, ideas?
Hello. Good. I think I have sort of two areas that I was curious about. One is you mentioned that the Bootstrap nodes need the 500 gigabytes. It's sort of a lot of computational resources in order to run these. Curious or conflicted, isn't the idea of the Bootstrap node that you just ask them, hey, who do you know? And then they return a list of peers. So why the overhead?
Yeah, absolutely. So that was the thing I mentioned earlier, the Hello protocol, which I blitzed through. So part of the Hello protocol involves exchanging your heaviest tip set. So your heaviest tip set isn't your latest tip set, it's your heaviest tip set, right? So they're supposed to agree on that for the handshake process. And that could be, quite far back. So that's the thing we're actually targeting, right? So we want to either remove that from the process or change that so it doesn't require like a heavy footprint on the disk. Yeah. So yeah, it's a good question, and that's something that we need to work on.
And the idea is that a Bootstrap node needs to be a model network participant, so it knows about the network, or
sorry, can you repeat that?
Sure. I'm just trying to understand. The Bootstrap node is keeping up with the chain is kind of the idea.
Yeah.
Okay.
Yeah, that's right. So that when it does the Hello protocol, it actually has the correct tip set to exchange.
That makes sense. Thanks. And then I'm curious. DNS feels very relevant and similar here. And one thing that comes to mind is where we have the list of Bootstrap peers, the 17. It's could be interesting to have maybe several resources where you can query via DNS and get that list.
So yeah, amazing point. So if I had more time, I would have gone into that. So that's actually particularly relevant in scenarios where the clients are subject to censorship. So you don't want to have a single point of failure. And like I mentioned, this data is delivered to you out of band. So let's say you were in an oppressive regime who didn't want you connecting to the Filecoin network. One mode of attack is to just block whatever Bootstrap list you're publishing online. So yeah, we should have a multitude of ways to access that same data. Yeah, it's a great point.
Thanks so much.
One final thing that I forgot, I just wanted to give a shout out to ChainSafe, who are looking at running a Bootstrap node in the near future. So that's part of the getting existing participants of the network to overload whatever they're running with Bootstrap functionality. So we look forward to that in the next few months. So thank you.